Hello everyone, so welcome back to our 30-day streak challenge, and it's a day 8. So we'll be solving our day 8 challenge, that is problem of the day. And let's see what's the problem today. Rat in a maze problem. It is asked in Amazon and Microsoft, and it's a medium level problem. We'll make it easy.
Hey there, coding enthusiasts. I'm Ampire and I'm thrilled to introduce you to my new daily quiz playlist on Python, Java, and C. Whether you are a beginner looking to hone your skills or a seasoned developer wanting to keep your knowledge sharp, these playlists are perfect for you. Just go to my channel, click on playlist section, and here you will find the treasure of tech knowledge sources. Each day I will be uploading new quiz questions to challenge you and help you master key concepts in Python, Java, and C++. As you can see, the 3 playlists are available here from day 1, day 2, day 3, day 4, and so on. Subscribe to my channel and hit the bell icon so you never miss a question. Let's learn and grow together. Happy coding, everyone.
So rat in a maze problem, I know about this problem because it's a popular problem for the topic backtracking. So here simply we have to use backtracking. Here the question is about, like, we have to start from the initial step. Will be placed at 0, 0, that is first location, and from here we need to find what are the all possible ways to reach this last point. So here you can see down, down, right, right. It means down, down, right, right. So this is one of the possible way. Another one is down, right, right. So down, right, down, down again, and right. So we are reaching this till this point. So question is very simple. Will be placed at this location. From here we need to find and figure out what are the all possible ways to reach this last point. You can see in this question we cannot see 1 here. It's 0, so there is no chance of reaching this point. So basically the question states that you can only travel in one's location, you cannot go for the zeros. Okay, so whenever there is a 0, there is abstraction, there is an abstract there. So you have to just it's just obstacle. So you have to just travel from here, but you cannot go for 0. You can only travel in the one's location, you cannot go for 0. So as it is 0 in the end, there is no possible way. Simply you have to return -1 here, right? So let's see. In case of no path, return an empty list. So empty list we have to return. So basically this is a string, this is a string. So we have to store the path in a string, and in the end, if it's a possible way, then we have to store it in our array list of string type, So let's work on it. And first of all, let's make a resultant variable of this type. So basically it's resultant is equals to new array list, and it's of string type string. So this list will have all the possible ways to reach the last place, like exact target location. So it will be holding all the paths. Like here you can see down, 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 right, right. It means it's one of the possible way. Then it is also one of the possible ways. So all the possible ways will be stored in a format of string. This is one string, this is one string. So we came to know that we have to maintain a string if and by storing each by storing each and every move in a string. If it reaches the last point, we'll just simply store that string in our resultant list. Okay, so what are the required things? So for this, actually it's a backtracking question, right? So we'll be implementing a separate function for this. Let's say public void. I don't require any return type for these. Public void, let's call our function as fun, and what we'll take two indexes, int I and int j for this. Let's say for a particular location in the matrix, right? And along with this, we'll definitely require a matrix. And as I said, it's a backtracking question, so we'll be like from a point we'll be moving in 4 different directions, that is up, down, left, right. So if let's say I'm on this location, then I have 4 possibilities. I can move up, I can go left, I can go down, but I cannot go for right because it's a 0 here, right? So like this we are having 4 possibilities. And let's say if I go up, and for this location I have again 4 possibilities, that is left, and no possibility for right, and there is no possibility for up, and there is a possibility of down. But I have already visited this. I said that we were here, from here we went to this, and from here there is a possibility to go down, but we cannot go down because it is already visited. So because of that visited stuff, we require an additional array called visited array. Let's say initially all the values will be like zeros in this, and again we'll require our resultant list, right, as a reference. Okay, let's pass this, and along with this we'll require a string which will be like storing all the paths. Let's say why string, because as you can see I have just prepared this str because as I said, it's I mean whatever the result is there, I mean if it's a successful path, it will be stored in a form of string. So initially we'll start from this point and we'll store all the our movements in the str string, and if it reaches our last point, then we'll simply store this stuff in our resultant. So let's say we have reached our last point, that is this one. So what will be the I and j parameters for this? So if for this I'm writing for this, because if we reach this point, it means we have reached our destination, right? So if I is equals to math dot length and along with this, and we require and j is equals to mat of 0, that is column, right? So dot length -1, because it's index based, right? So -1, and this is also -1, and mat dot length -1, j is equals to mat dot length -1, and along with this it should be 0, right? Sorry, it should be 1, because as we have seen, we can reach this point, but it should be 1 here, right? If it's not 1, then what's the use? So we'll also maintain a condition, and mat of I j should be 1. And in that scenario you have reached the correct location. So simply result dot add whatever your travel path, that is stored in string, right? Whatever your travel path is there, that will be stored in string, and result dot add that string, and simply return from here. Okay, let's now write for other conditions. Let's say if we have reached now, as we are like dealing with ij as indexes, right, there might be a possibility that this I will go up, so it will be like less than 0, right? Let's say I and j, right? So I and j value for this is 0, 0. There are four possibilities: left, right, up, and down, but there is no value in the up. So it means if our I value is less than 0, or else our j value is less than 0, or else there is another condition. Let's say we are going out of like j, right? I mean from here also there are 4 possibilities. If we reach the last point, there are 4 possibilities that we can go down. Let's say this one, there are 4 possibilities. We can go up, we cannot go for left because it is 0. We can go for right, and we can go for down, but down there are no values, right? Because of that reason I'm going to mention this condition also. If I greater than or equal to math dot length, right, and along with this j is greater than or equal to math 0 dot length. In that scenario, simply return back, because there is no point to like visit that stuff, because there is no existence of anything there, right? And now again let's write for some other condition. If our mat, whatever mat is there, mat ij, that current location, let's say that current location is equals to 0. If it is equals to 0, then also there is no point of being at that location. Let's say from here I can go in the right, up, left, and down. So I went on right. So when I came to write, I saw that mat of ij is equals to 0. So there is no point of visiting that location, right? Because I mean, we cannot visit 0. We can only travel by that path of 1, right? So with 0, we'll just return back. Now, after that, okay, along with this, as I said, we are going to visit each and every ij, right? We are visiting every value here. So for that, we'll write a condition. If it is before that, if it is not visited, then only we can visit the stuff, or else we will mention another condition here. If visited of ij is equals to 1, if it is visited, then also return back. For example, I'm on this location, right? If I'm on this location, let us consider this example. If I'm on this location, I can go up, down, left, right, but left part is, let's say, already visited. So there is no point of visiting this one. We can have only 3 options, that is up, right, and down. If it is already visited, if the left side is already visited, so for that reason I'm going to check if it is visited, then also return back. Okay, if it is not visited, then we'll come to line number 47, and we will mark here, first of all, visited. Let's mark it as visited, because visited of ij is equals to 0. That's the reason you are coming for line number 47. Otherwise you will get written in at line number 45 itself. Okay, so now let's call the function calls. We are having 4 function calls. That is, let's say we are going up, so I minus 1 comma j mat, and along with that visited array, along with that resultant, along with that string, plus what's the direction? Up, right? So for that up, we will be using u. So just simply add here u. So this function will go for up. Along with that, it will mention where it is going. It is going up. That's the reason we are writing str plus u. Now let's say we are going down. So I plus 1 comma j mat visited resultant str plus down, right? Now function, let's say left, j minus 1 matrices visited resultant string plus left, and function I, and we'll be visiting right side, and mat visited resultant str plus right, up, down, left, right, done. All right. Okay, so okay, after as in this question we are trying to figure out all possible ways. It means from here it will go and check for the right side direction, and is it reaching till last point or not. After that, if it is reaching, okay, fine. Now again from here it will check from down path, is it reaching for all paths or not. So it means you are going to visit them again and again, right? So if you mark a location, from this location I'm getting a solution, right? So after that, mark it as unvisited before leaving. So this is the point where our backtracking actually comes to use. This is the actual use here of using backtracking. So just be at a location. Let's say I'm at this location. Just be at that location and check for all possibilities. If you are going to get solution, it's okay, it will be stored automatically because of this condition. And if you return back, now you have other opportunities to visit. You have to visit all possible ways. After visiting all possible ways, now you have to like go for the next location, right? Or else you have to return back. Before returning, just you have to mark it as unvisited, right? So if you don't do this, then you are going to get only one solution, that is only one path. You are not going to get the multiple paths. Here we need multiple paths. That's why we have to mark it as unvisited in the end. So that's it. Let's try to run this solution. Compile and run. Oh shit, we didn't made any function calls, right? So int and then int visited is equals to new int math dot length and along with this mat of 0 dot length. So our visited 2D array size will be similar to that matrices, and now we'll do function call. I and j value will be initially 0 and matrices as usual, visited array along with our resultant array list and str which will be empty initially. And after this function call will be made, and in the end we'll return res. Okay, let's submit this code. Oh yes, so all the test cases are getting passed, and see how successfully we have solved a problem of the day for day 8. So continuously we have been solving all the problems since 8 days, and we'll be continuing this. So that's it for today. I hope you like this video. Thank you. Bye bye.